Our first lecture is going to go into chemistry and the different fields of chemistry, as well as talk about some historical figures that contributed to what chemistry is today. So chemistry is the study of matter, and when you take science classes in high school, they typically divide them up into different hats. So you have physics, you have chemistry, you have biology class, you have earth science class, but really science is a hierarchy of different types of sciences that are all intertwined, okay? And they all start with math. So math is used in physics in order to explain the motion and the movement of objects around us and how, objects interact. So Newton developed calculus, okay, in order to explain physics. Physics, during your physics classes, if you choose to take physics or have taken it already, in physics we learn about the interaction between charged particles. The interaction between charged particles is really the basis for chemistry, how atoms interact, how elements interact to form compounds, why chemical reactions occur. Chemistry then is also the basis for biology, because biology is the study of life, but all living things are made up of chemical compounds. So you can see how there is a hierarchy that begins with math, and all of those subjects are really intertwined, even though, in high school and college we teach them like they're separate entities. So there are 5 different branches of chemistry. The first is inorganic, then we have organic, then we have analytical, physical, and biochemistry. So I'm going to go into detail a little bit about what those branches are and what we study in those branches of chemistry. The first is inorganic chemistry. So inorganic chemistry is the study of chemicals that do not contain carbon. So inorganic chemistry is the study of acids and bases and other sorts of chemical compounds, solvents, cleaners, and things like that. Whereas, oppositely, organic chemistry is the study of things that contain carbon. So carbon is the basis of all living organisms. Okay, all organic molecules or biochemical molecules are made up of carbon chains or carbon rings. And so organic chemistry is the study of chemicals that are in living organisms. So if we look at these examples of different chemicals here, you can see that we have the name, so sulfuric acid, and then we have a formula. So a sulfuric acid's formula is H2SO4. So that would be considered inorganic because it doesn't involve carbon. Methane is CH4. C is the symbol for carbon, so methane is actually an organic molecule. Then we have hydrochloric acid. Although hydrochloric acid has a C in its formula, the C is actually attached with the Cl, meaning that that's the symbol for chlorine and not for carbon. So hydrochloric acid is another example of inorganic. And then ethane, of course, C2H6, another carbon compound, so that is considered organic. Analytical chemistry is done in order to discover the composition of matter. So if you like watching any shows like CSI or any of the forensic shows, they use analytical chemistry a lot. They use machines called mass spectrometers or gas chromatographers, and the function of those machines is to determine the chemical structure of an unknown or unidentified compound. So say, for example, at a crime scene we find a white powder and we're not sure, it could be crushed up aspirin, it could be cocaine, it could be sugar, and we can take that unknown compound and we can use these instruments in order to figure out the exact chemical structure. That's what an analytical chemist does. A physical chemist studies matter as it undergoes change. So they study chemical reactions. They want to know the mechanism, how a chemical reaction is occurring. They want to know the rate at which it occurs and what the energy transfer is, the amount of energy that goes from one system to another. Okay? So a physical chemist is somebody who understands why and how exactly chemical reactions occur. And then lastly, we have a biochemist. So a biochemist sort of bridges between chemistry and biology. So they review or learn the processes that take place in living organisms. So all of the molecules that make up a cell, you learn about them in biology. They're the four major macromolecules, right? So you have nucleic acids, you have proteins, you have lipids, and you have carbohydrates. And those are all organic molecules that are the building blocks for the cell. Okay? They are also involved, they're not only involved in the structure of the cell, but they're involved in all the processes. So if you look here, you can see this big complicated mess. You might recognize it, you might not. You've learned about it in biology. This, it shows glycolysis. So we start with glucose, which is a carbohydrate. It's a ring of carbons with hydrogens and oxygens attached. And glycolysis, the process of glycolysis, is to take glucose and sort of change its shape and do a bunch of things in order to get ATP, which is the energy molecule. So a biochemist is somebody who really gets down to the structure of the chemical compounds that are taking place in order to produce those energy molecules. Okay, so science and technology are typically put together and used, interchangeably, but they're actually different things. Pure science is science that doesn't necessarily have a direct application. We're trying to look down at a small level and see why and how things happen. Technology is when we apply that science. So we are able to take what we learn through scientific experimentation and create something usable. Build your iPod, build a bridge, engineering. Okay? These are all the application of technology. So just to give another example, somebody who is a scientist might study how aspirin forms and look at it on a very small scale level. So that's somebody that's looking at the compound, that's looking at these carbon rings and at the bonds between these carbons and oxygens and understanding why and how it forms or interacts. Okay? A technologist is somebody who would then take that aspirin and mass produce large amounts to be distributed to a consumer. Okay, so that is taking the application of what we learned about aspirin and how and why it interacts and applying it to some use like a medication. Alright, so just we're going to do a brief overview of some historical figures that are important in the history of chemistry. So Aristotle, amongst other early philosophers, were called natural philosophers. These were the first scientists. Natural philosophy meant they studied nature around them and they were lovers of knowledge, so they wanted to know about the world around them. And in the 4th century BC, he came up with the idea of elements. He thought there were 4 major elements that made up of all matter, and they were earth, water, air, and fire. Of course, now we know that that is not correct. Around the same time, a little bit later, we had Democritus, and he came up with the very first atomic theory. And he was another Greek natural philosopher. And he came up with the idea of an atom, that all matter was made up of these small, indivisible particles called atoms. Right? And for a very long time, that was the only atomic theory that we had. More atomic theories developed later, and we'll talk about that in a second. Between the time of Democritus and the 1700s, we had this field of alchemy. And that is where the word chemistry came from. So alchemy was performed all over the world, and the 2 intentions for alchemy were, one, to be able to change metals into gold, for obvious reasons, money and power, but also there were mystical properties in order to they thought they could make something called the Philosopher's Stone, which would make you be able to live forever. Okay, and you might recognize that from Harry Potter. We'll talk about that here in a little while. But what was good about alchemy, although we know now that it's not a real science, is that through all of these experiments that the alchemists did, we learned a lot about chemical experimentation. We learned a lot about lab equipment. They developed procedures. There were some medicines developed. So a lot of good came out of it, although, what the purpose of alchemy didn't really come to fruition. And another very important chemist, he's actually the father of chemistry, is Antoine Lavoisier. And in the 1700s, what he did was he took science from a qualitative to a quantitative process. So qualitative means you're looking at observations. Quantitative is when you're using numbers. So he really started a science of exact measurement, okay, so that we could use math to analyze our scientific experimentation. Okay. Now there's other things that he did. He also made a lot of lab equipment. He discovered nitrogen, and he also discovered the law of conservation of mass, which is fundamental to chemistry, and we'll talk about that a little bit later. Then after Antoine Lavoisier in the 1700s, we started again to develop more of an atomic theory. And John Dalton was one of the first to come out and discuss atoms more in detail. He began to develop a list of elements and give those elements symbols, and to develop an atomic theory. And we'll discuss him and his atomic theory later when we go more into detail about atoms. I believe that's in Unit 2. Okay, Amadeo Avogadro, you may have heard of Avogadro's number at 6.02 times 10 to the 23rd, but he developed a unifying way of measuring particles in chemistry. So 1 mole of any substance contains 6.02 times 10 to the 23rd particles. So this is really important, and we'll talk about him later. We'll bring him up later when we learn about molar quantities and how to measure moles in chemistry. And lastly, I want to talk about Dmitry Mendeleev. Dmitry Mendeleev, we have been over the past centuries before he came along, discovering more and more elements, and he is the first person to put together a periodic table of elements. So he started to organize those elements based on their properties, and by doing this, what was so great about his periodic table is that you can see on the periodic table that it began to develop holes. Okay, and holes in the periodic table helped us to discover the elements that should have been there. Okay, so Dmitry Mendeleev made the first periodic table. So that's just an overview of some interesting historical figures, and again, we'll be mentioning them again as we learn about their discoveries and what we know about now.